Good day, Algebra. We are continuing talking about CO11, and we're going to go over the homework, which we don't usually do on the recording, but we're going to go straight from this expanded form epiphanies, realizations to the rule. And I want to make sure that we capture the magic on the YouTube video. So I'm going to, Okay, so your job here was to write each expression in expanded form. Okay, and then simplify it to be one term. And the reason why I'm harping so much on expanded form is because if you forget what the rule is, you can always go back to expanded form as a safety net. Because we can see what's going on here. 9 to the 6th is 9 times 9 times 9 times 9 times 9 times 9. Right? 9 to the 4th is 9 times 9 times 9 times 9. And what are we talking about we can do here? How can we simplify this down? And if you weren't here, make sure you're not just writing down the answer. Write down how we get there, okay? Because this expanded form piece is critical. What can we do? Yeah. Canceling out pairs of 9s, right? Because what's anything divided by itself? 1, okay? 9 divided by 9 cancels out, cancels out, cancels out, cancels out. And what we're left with here is 9 times 9, or 9 squared, in the numerator, okay? What's left in the denominator here? What's left in the denominator? All those 9s canceled out. What's left? Yeah, a 1, not 0, okay, a 1. The thing about a fraction is that if your denominator is 1, you don't have to actually write it. But if you wanted to, you could put 9 squared over 1, okay? 9 squared over 1. Next one, c to the 5th times c squared. We got c times c times c times c times c over c squared, which is c times c. What's c divided by c?
C.
No.
By 1.
1. Anything divided by itself equals 1. So whether it's a number or it's a variable, we can do the same thing and cancel out those pairs of c's. How many c's do we have left?
3.
And where are they?
The numerator.
The numerator. So our answer is going to be c cubed, right? And if you want to put the over 1, you can. You don't have to. But c cubed over 1. Next one, 2 to the 8th over 2 cubed. 2 times 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 2 over 2 times 2 times 2. What's 2 divided by 2? Everybody. 1. Anything divided by itself equals 1. So those 3 pairs of 2's get canceled out. We have 5 2's left. They're in the numerator. And so our answer is going to be 2 to the 5th power. If you want to put it over 1, you can, but you don't have to. Okay. Now, at this point, maybe you're starting to recognize a few patterns, a few connections. What are you seeing here that is consistent and could potentially lead to the shortcut? Josie? What do you mean they're the same?
The same number and letter.
Okay, and that's why this rule is called dividing by the same base, right? We have 9 to the 6th over 9 to the 4th, c to the 5th over c squared, 2 to the 8th over 2 cubed. I want you to look at the powers. Look at the powers in the original expression, and then look at the exponent in our answer. Are you seeing anything in particular? Nolan?
You can just subtract 6 by 4 and you get 2.
Yeah, it seems to me that if you take your powers and you subtract them, 6 minus 4 equals 2. Notice the power on our answer is 2. You take 5 minus 2, that equals 3. Notice that our power on our C is 3. You take 8 minus 3, you get 5. Notice how the exponent on our answer is 5. That's a pretty big deal, isn't it? Because if you look on the next page here, you want to know how to become world's least favorite teacher? Have you write something like that out in expanded form, right? No one wants to do that. Okay, so this rule that we are developing today is going to be very, very helpful. Let's see if it holds here throughout the rest of these. This next one now, h to the 5th over h to the 7th, h times h times h times h times h. This time I've got more h's in my denominator. I make an extra h? I think I made an extra h. Whoops. There we go. Okay. What's h divided by h? Peyton? What's h divided by h? 1. So cancel out, cancel out, cancel out, cancel out, cancel out. How many h's and where are they? How many h's do I have left over and where are they? This is a little bit different from the 3 up at the top. Anthony?
There's like 1 h in the numerator and 2 h's in the denominator.
Where do you see the h in the numerator?
It's just 1.
It's just 1. Not 1h, right? Because if there was still an h in the numerator, we'd cancel it out. Okay? Every h that was in the numerator is no longer there. And so when we write this answer, we have h squared in the denominator. Our numerator has to be 1. When your denominator of a fraction is 1, you don't have to write it. When the numerator of a fraction is 1, you do need to write it. Otherwise, how do we know that this is in the denominator? Okay, we have to show that, right? But don't have h over h squared because there are no h's up here. But going back to what Josie mentioned earlier, 7 minus 5 equals 2. 2 is still our exponent, but this time it's in the denominator. How do we know whether our leftover bases will be in the top of the fraction or the bottom? The top 3, they all ended in the numerator, right? So it's always over 1, over 1, over 1. Here, it's in the denominator. How do you know where to put it?
Because the bigger exponent is on the place that you're gonna.
Exactly. Where do you have more h's to start with? We had more h's to start with in the denominator, so that's where our leftover h's are going to be. Up in the top, we had more c's or 2's or 9's, whatever it was. In the numerator, that's why they were left there. Okay? So where we have more to start with, that's where your h's are going to go. Next one. 8 times x times x times x times x times y times y times y. 8x to the 4th, y cubed. Over 4. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. Yowza. That was not very fun. What can we cancel out here? Some we haven't heard yet today, perhaps. What can we cancel out? Nolan?
Oh, the 3 x's. And then like the 3 y's. Or the 2 y's.
Looks like we can cancel 4 x's.
Oh,
right?
Yeah, that's what I meant.
And then we have 1 x left over that can't cancel out with anything because we're out of x's.
And then you can do the 3 y's.
And then we cancel out 3 pairs of y's, and it looks like we have 2 of them left. Okay. How about the 8 and the 4? Are they coefficients or are they bases? No, the coefficients. And what did we say that we could do with coefficients? How do we handle them? Remember from the very first 3 examples that we did last week, Thursday. Yeah.
Multiply.
We don't multiply them. That's if we're multiplying by the same base. Here, we treat them like a fraction. 8/4 simplifies to be 2 over 1. Right? 8/4 simplifies to be 2 over 1. So, what do we have left in our numerator? We have a 2. What do we have left in our denominator? We have a 1, which we don't have to write, but we have an x, and we have y times y, which we can write as y squared. So 2 over xy squared is the answer. Did y'all get that? Okay, again, this is going over homework, so make sure you're checking your answer, asking questions if you didn't get it correct. Yeah, sure, it'll cost you a pass. All right. Then the next one, 10xy squared over y to the 4th, last one on the page. 10, how many x's are there? 1 or 2?
There's 1.
Just 1, right? That y squared only applies to the y. So 10 times x times y, and then in the denominator, we have 1, 2, 3, 4. I'm being very intentional as to where I'm writing my variables so I can line them up. I can see how many I have left over. I don't accidentally cancel out an x with a y, right? Don't want to do that. Y and y can each be canceled out. What are we left with? 10x in our numerator, y squared in the denominator. And we are done. Why can't we cancel out that x with one of the y's? Why can't we cancel out an x with one of the y's? Okay. Why can we cancel out a y over a y? Anthony?
Isn't it the same thing?
Because anything divided by itself equals 1. We don't know what y is, but we know it's the same, right? If we have x and y, x is different than y, we can't cancel them out. Because something divided by something different is not going to equal 1. The only way to get 1 is something divided by itself. Okay. Questions on the homework then? All right. So for the rule, come back up to the top. This is what can go in a help sheet. We already said that the exponents get subtracted. We identified that relationship, and it's true. Okay. What do we do with the coefficients?
Divided.
I'm going to use a different.
Simplify.
Yes, very good. Okay. I don't want to say divided because even though in the one that we had here, 8 divided by 4 did equal 2, there's one up above this, the first example that we did, which had a 9 and a 12. We didn't divide 9 and 12. We simplified 9 and 12, right? If you look back at your work from up above, you should have a 9 crossed out with a 3 and a 12 crossed out with a 4. That's because we simplified the fraction 9/12. You don't want to divide it and have a decimal. Okay? Simplify. So coefficients, simplify, and in parentheses, I'm going to put like a fraction. Okay. Simplify like a fraction. The exponents are subtracted. And the base, we had 9 to the 6th over 9 to the 4th. We got 9 squared. C to the 5th over c squared. We got c cubed. 2 to the 8th over 2 cubed. We had 2 to the 5th. What happens to the bases? What? I heard someone say it. Stay the same. Okay, stays the same. So if you're thinking, my gosh, that's like the exact opposite of what we do in CO10. In CO10, when you multiply by the same base, the coefficients are multiplied. Here they're simplified. The exponents in CO10 were added. Here in CO11 they're subtracted. That's because multiplication is the exact opposite of division, right? They're opposite operations. So if we're doing the opposite thing, then our rule is going to be pretty much the exact opposite. So, armed with this knowledge, let's go back to the end of the 100th y to the 61st, which I don't want you to write out in expanded form, right? Let's all read the directions here. The goal is to not have to write each expression in expanded form, but instead use the rule. What are we going to do here?
6 minus 3.
We're on, talking about the n to the 100th y to the 61st, the one that I pointed out earlier. Using the rules, we don't have to write this out in expanded form. I do not want to become the world's least favorite teacher. What are we going to do instead? Maya?
Don't you do 100 minus 65?
Yeah, we have a base of n here, right? We take those powers, 100 minus 65 equals 35, okay? In expanded form, we can visualize that these 65 n's will cancel out with 65 of the 100. So where are those extra 35 n's going to be? Are they going to be in the numerator of the fraction or the denominator? Numerator. We had more there to start with, right? So n to the 35th, and then we have the second base of y to the 61st over y to the 102nd. What are we going to do here? Again, using the rule. Landon, I see you number crunching away. What are you typing in?
61 minus 102.
Now, 61 minus 102 is going to give you a negative, okay, which isn't wrong as long as you understand what that means, right? I would advise you instead to start with the bigger number, 102 minus 61, and that's going to get you 41, okay? If you took 61 minus 102, you get negative 41. So 41 is still prevalent there, but where are those 41 y's going to go? In the numerator of the fraction or the denominator of the fraction? Regan?
The denominator.
Denominator. Why? Because we have more there to start with. Right? We have more there to start with. So your final answer here is n to the 35th over y to the 41st. Man, that rule is nifty. What a time saver. Now you still have time tonight after your homework to go out and rake leaves and stuff. Final touches on Halloween costumes, right? Okay. Pick another one that we can see here. Don't go down past this yet, but pick one that we can see for us to do together. Tristan.
The one before the one we just did.
The 24, d to the 5th, and the 13th? Okay. So, again, not needing to write this in expanded form, let's take a look at what we have. Do we have coefficients? What are they?
D.
D is a base. Remember, coefficients are always numbers. They're the numbers that come before the base. So in this case, they are 24 and 20. Okay? And so these being coefficients, and this is why we talked about in PO9, it's important to know what these different pieces are. Okay? Because if you read the rule and it says, oh, coefficients, simplify. Well, I don't know what the coefficients are. Then the rule's not going to be very helpful. Right? But yes, 24 and 20 are the coefficients. And according to the rule, we simplify them like a fraction. So what is 24 20ths simplified to be? 24 20ths. Yeah. So 1 and 1/5, that's a mixed number, so it's not wrong. However, we don't really use mixed numbers anymore. So what is that as an improper fraction? 1 and 1/5, that's an improper fraction. Yeah, 6/5, right? You can divide 24 by 4, divide 20 by 4, and you get 6 and 5. So in our final answer, we know our numerator will have a coefficient of 6, and our denominator will have a coefficient of 5. So I do not want you to use mixed numbers. I don't want you to use decimals. Treat it like a fraction, but keep it as an improper fraction if it already is one. So now we go to our bases, and we have d to the 5th over d squared. How many d's are left over, and where are they? And our final answer, how many d's will we have left, and where will they be? Zoe? 3 in the numerator or denominator? Numerator, right? We have more there to start with. We have 5 of them compared to 2 of them. 5 minus 2 equals 3. And again, if you think about what's going on in expanded form, these 2 d's are canceling out with 2 of them from the top, leaving you with 3 of them, right? So 6d cubed. Then we go to our next base, which is just this g by itself here. Can we cancel that g out with anything? Do we have any other g's anywhere? No. So it's going to stay in the denominator of the fraction. And then finally, we look at our n's. N to the 13th over n. How many n's will we have left, and where will they be?
12.
12 of them, right? Don't forget, this n is a power of 1. It's not written, but it's there. So the rule states we're going to subtract 13 and 1 to get 12. And where will those 12 n's be? Numerator or denominator? Numerator. Because we have more there to start with. So final answer, 6d cubed n to the 12th over 5g. Fantastic. All right, let's look at the bottom row. Any of these that you want to talk about? I have my prediction, but I'll let you, whoops. Dominic!
The last one?
The last one. So this is where we kind of combine rules a little bit. You see we have a fraction, so you know that we're dividing by the same base, but you also see this multiplication symbol, which kind of brings us back to CO10. So can rules kind of be interchanged? You bet. And what I advise you to do is to take care of the numerator and the denominator separately. So we're just going to look at our numerator first. 4n to the 5th times negative 12n to the 9th. What does that simplify to be? 4n to the 5th times negative 12n to the 9th. Think back to CO10 now. Think about what happens to the coefficients, what happens to the bases, what happens to the powers. Who has an answer? Yeah?
Is it 48 n to the 14?
Good job. Yeah. Okay. 4 and negative 12 are the coefficients. They get multiplied. It actually ends up being negative 48. Okay. But yeah, 4 times negative 12, negative 48. That's our coefficient. And in this rule, the exponents get added. So we get n to the 14th. Okay. Now we're going to look at our denominator, deal with just that by itself. What does that simplify to be? Negative 9n squared times 4n to the 4th. Negative 36 n to the 6th. And now that we've done each of them separately, now we can put them together. And we can say, okay, what does this fraction simplify to be here? So, like the others, we look at our coefficients, treat it like a fraction. What is negative 48 over negative 36? What does that simplify to be? Dominic?
Negative 4.
Close. We do get 4 and 3 from the 48 and the 36, but what's a negative divided by a negative?
Oh,
Positive. So those will cancel out also. Okay? So negative 48 over negative 36 divided by 12. That gives you 4 over 3, cancel the signs. Then we have our n's, our base of n's. Using this rule now, the powers get subtracted. 14 minus 6 is 8. And so our final answer, 4 n to the 8th over 3. And how do I know those 8 n's go in the numerator? Because again, that's where we had more n's to start with. Okay? Questions on this? Your homework is the rest of the page, the rest of CO11. We are going to talk about this bottom part a little bit. It says, write an expression that would simplify to be the following. So it's like I'm giving you the answer. You're giving me an expression that we could have started with. And there's an infinite number of correct answers here. But to end with x to the 12, who's got an idea for what our starting expression could have been? To get x to the 12th as an answer. Well, maybe to get your brains going a little bit, how about x to the 15th over x cubed? If we started with that expression, would we get x to the 12th as an answer? Yeah, we would, right? Because 15 minus 3 gives us 12. What's another option? What's another expression that you could have started with to get x to the 12th as an answer? Adrian, what are two numbers that subtract to 12?
two things that subtract to be 12.
Yes.
14 minus 2.
Sure. You could have also started with x to the 14th over x squared. Right? That would also give you x to the 12th as a final answer. So again, I'm giving you the answer. You're giving me what could the original expression have been. And there's an infinite number of correct answers to this, because there are a lot of ways to get 12. Questions, comments, concerns, complaints, compliments, congratulations, criticisms on this? Very well. You've got 7 minutes to work. This is due tomorrow. That is how you math.